Download this code from codegive.com, link in the description below. Deepseek Unleashed, a deep dive into deployment, configuration, and integration. Deepseek is a powerful open-source language model gaining popularity for its capabilities in code generation, reasoning, and general text processing. Deepseek Unleashed often refers to using Deepseek beyond its initial training data and capabilities through fine-tuning or integration with external tools and applications. This tutorial will cover the deployment, configuration, and integration of Deepseek with code examples, equipping you to leverage its power in your projects. Part 1: Setting up your Deepseek environment. Before diving into the code, let's establish the foundations. 1. Choosing a deployment method ****. Deepseek can be deployed in several ways, each with its pros and cons. Local deployment, recommended for development and experimentation. Benefits ***, full control over your model, no internet dependency, reduced latency. Drawbacks requires significant hardware resources, GPU with sufficient memory, more complex setup. Tools Hugging Face Transformers, VLLM, Llama.cpp, for CPU inference. Cloud-based inference services, recommended for production. Benefits scalability, managed infrastructure, often optimized for performance. Drawbacks internet dependency, potentially higher cost, less control. Platforms AWS SageMaker, Google Cloud Vertex AI, Azure Machine Learning, RunPod, Replicate. Serverless functions, suitable for API endpoints. Benefits cost-effective for infrequent usage, easy scalability. Drawbacks cold starts can introduce latency, limitations on execution time and resources. Platforms AWS Lambda, Google Cloud Functions, Azure Functions. 2. Hardware requirements, for local deployment. The most crucial factor is the GPU. Here's a rough guideline. Small models, example Deepseek Coder 1.3b 8GB VRAM, might require quantization. Medium models, example Deepseek Coder 6.7b 16GB VRAM, quantization is recommended for better performance. Large models, example Deepseek 33B, Deepseek Coder 33B 32GB plus VRAM, essential for full precision inference. You'll also need a decent CPU and sufficient RAM, at least 16 GB, to handle data loading and processing. An NVMe SSD is highly recommended for faster loading times. 3. Software setup, local deployment with Hugging Face Transformers. Python ensure you have Python 3.8 or higher installed. Virtual environment, highly recommended. Install dependencies Important notes about CUDA/ROCm replace CU118 with the appropriate CUDA version supported by your GPU driver. For ROCm, ensure your AMD GPU is supported and ROCm drivers are correctly installed. Consult the PyTorch website for the most accurate and up-to-date instructions. If you're running on a CPU-only machine, the CPU version of PyTorch will be installed automatically. Part 2, Basic Inference with Hugging Face Transformers. Let's start with a simple example of using Deepseek Coder 6.7b for code generation using the Hugging Face Transformers library. Explanation ***. 1. Import libraries *** imports the necessary classes from the Transformers library. 2 Model selection * sets model _ name to the Hugging Face repository name of the Deepseek Coder 6.7b model, or another Deepseek model you prefer. 3 Load tokenizer and model * loads the tokenizer and model using auto tokenizer and auto model for causal LM. Trust _ remote _ code equals true is crucial as some models might have custom code components. The model is then moved to the GPU using .2, CUDA. If you don't have a GPU, remove this line. 4 Prompt engineering * defines the prompt that will be fed to the model. Well-crafted prompts are essential for getting good results. 5 Tokenization * the tokenizer converts the prompt text into numerical IDs that the model can understand. Return _ tensors equals PT specifies that PyTorch tensors should be returned. 6 Code generation * the model.generate method performs the code generation. Key parameters. * max _ length sets the maximum length of the generated code, including the prompt. * do _ sample enables sampling. If false, the model will generate the most likely sequence, deterministic. * top _ nucleus sampling considers the smallest set of tokens whose cumulative probability exceeds top _ p. Good for controlling the diversity of the generated text. * top k sampling chooses only from the top k most probable tokens. * temperature controls the randomness of the sampling. Lower values, example 0.2, make the output more deterministic. Higher values, example 1.0, make it more random. Number _ return _ sequences, the number of sequences to return. 7 Decoding and printing * the generated token IDs are converted back to text using tokenizer.batch _ decode, and printed. Skip _ special _ tokens equals true removes special tokens, like s/s, from the output. Part 3, Advanced Techniques and Integrations. Now, let's explore some advanced techniques to enhance Deepseek's capabilities and integrate it into more complex applications. 1. Quantization ***. Quantization reduces the memory footprint of the model, allowing you to run larger models on less powerful hardware. It involves converting the model's weights from higher precision, example float 32, to lower precision, example int 8 or float 16. Using bits and bytes ***. Note * you may need to adjust the device _map argument based on your GPU setup. Auto is often a good starting point. Install bits and bytes using pip install bits and bytes. 2. Using VLLM for high throughput inference ***. VLLM is a high-performance inference engine that significantly improves the throughput and latency of large language models. Installation * pip install VLLM. Example ***. Benefits of VLLM ***. Paged attention * efficiently manages attention memory, reducing memory fragmentation. Continuous batching * processes multiple requests concurrently, increasing throughput. Tensor parallelism * distributes the model across multiple GPUs for faster inference, requires appropriate setup. 3. Fine-tuning Deepseek ***. Fine-tuning adapts a pre-trained model to a specific task or data set, often leading to significant performance improvements. This is where Deepseek Unleashed truly comes into play. Preparing your dataset * Your dataset should consist of text pairs, input, instruction, output, completion. Save it as a JSON-L file, one JSON object per line. For code generation, Your dataset might consist of function descriptions, input, and corresponding code implementations, output. Asterisk using LoRa, low-rank adaptation. LoRa is a parameter-efficient fine-tuning technique that only updates a small number of parameters, reducing memory requirements and training time. Explanation asterisk. Asterisk dataset preparation asterisk loads your JSON-L dataset using load_dataset and tokenizes the input and output pairs using the preprocess_ function. Asterisk LoRa configuration asterisk defines the LoRa configuration, including the rank, R, alpha, dropout, and crucially, the target_modules. Target_modules specify which layers of the model will be adapted by LoRa. Common choices for causal language models are the query, Q_proj, and value, V_proj, projection matrices in the attention layers. Experiment with different target_modules for optimal results. Asterisk training arguments asterisk configures the training process, learning rate, batch size, number of steps, etc. FP16 equals true enables mixed precision training for faster performance. Optim equals paged_atomu_32-bit uses paged atom W, which is memory efficient, especially for large models. Asterisk trainer asterisk creates a trainer instance, which handles the training loop. The data_collator is a function that prepares the data for training. In this case, it stacks the input_ids, attention_mask, and labels, which are the same as input_ids for causal language modeling, into PyTorch tensors. Asterisk training and saving asterisk starts the training process using trainer.train, and saves the fine-tuned model and tokenizer. The saved model will contain only the LoRa weights, not the entire model. Asterisk inference with the fine-tuned model asterisk. Key points asterisk. Asterisk you first load the base model, example Deepseek AI/Deepseek Coder 6.7b base. Asterisk then, you load the LoRa adapter weights using peft_model.from_pretrained. Asterisk the adapter is merged with the base model during the forward pass. Asterisk make sure to set the model to evaluation mode, model.eval, before inference. 4. Integrating Deepseek with external tools, example, code analysis with Pylint. This example demonstrates how to use Deepseek to generate code and then analyze it with Pylint to identify potential issues. Explanation asterisk. 1 Code generation asterisk. The first part is similar to the basic inference example, generating Python code based on a prompt. 2 Saving to a file asterisk. The generated code is saved to a file, generated_code.py. This is necessary for Pylint to analyze the code. 3 Running Pylint asterisk. The subprocess.run function executes the Pylint command on the generated file. Capture_output equals true captures the output of Pylint. Text equals true ensures that the output is treated as text. Check equals true raises an exception if Pylint returns a non-zero exit code, indicating errors. 4 Printing Pylint output asterisk. The output of Pylint, or any errors, is printed. 5 Cleanup asterisk. The generated file is deleted, optional. Key considerations asterisk. Asterisk error handling asterisk. The try, except block handles potential errors from Pylint, example if Pylint is not installed or if the generated code has syntax errors. Asterisk tool integration asterisk. This example illustrates a general pattern for integrating Deepseek with external tools. You can adapt this approach to integrate with other code analysis tools, testing frameworks, or even version control systems. Asterisk security asterisk. Be very careful when running generated code, especially if it interacts with the file system or network. Sanitize inputs and outputs to prevent security vulnerabilities. Part 4, Deployment Options and API Development. 1. Deploying with Fast API and Unicorn, creating an API endpoint. This is a popular method for creating a simple and efficient API around Deepseek. Install dependencies *pip install FastAPI Unicorn transformers torch. *main.py, your API code. Run the API Unicorn main app reload. The -reload flag automatically reloads the server when you make changes to the code. Explanation Fast API setup creates a Fast API application, app. Model loading loads the Deepseek model and tokenizer. Data models, Pedantic defines pedantic models, code generation request and code generation response, to specify the input and output data structures for the API. This provides automatic validation of the input data. API endpoint, /generate_code. The @app post decorator defines a post endpoint at /generate_code. The generate_code function handles requests to this endpoint. It takes a code generation request object as input, extracts the prompt and generation parameters, generates code using the model, and returns a code generation response object. Error handling is included using a try, except block to catch exceptions and return an HTTP 500 error. Running the API the Unicorn command starts the Fast API server. Testing the API You can use tools like curl, hp, or Postman to send requests to the API. For example, using curl. 2. Cloud deployment, example, AWS SageMaker. Deploying to cloud platforms like AWS SageMaker involves creating a Docker image containing your model and API code, and then deploying it to a managed inference endpoint. This provides scalability and reliability. Dockerfile requirements.txt contains your dependencies, same as before. Main.py the same Fast API code from the previous example. Building and deploying the Docker image to SageMaker this involves several steps. 1. Build the Docker image Docker build t Deepseek API. 2. Tag the image Docker tag Deepseek API latest your _AWS account _ID.dkr.ecr your _AWS region.amazon aws.com/Deepseek API latest. 3. Authenticate with ECR follow the AWS documentation to authenticate your Docker client with Amazon ECR. 4. Push the image to ECR Docker push your _AWS account _ID.dkr.ecr your _AWS region.amazon aws.com/Deepseek API latest. 5. Create a SageMaker model use the AWS SageMaker console or SDK to create a SageMaker model, specifying the ECR image URI. 6. Create a SageMaker endpoint configuration configure the endpoint, instance type, number of instances, etc. Choose an instance with a suitable GPU, example milliliter G5. Large or larger depending on your model size. 7. Create a SageMaker endpoint create the SageMaker endpoint using the model and endpoint configuration. 3. Serverless deployment, example, AWS Lambda. Important points for Lambda deployment. Model loading optimization load the model and tokenizer outside the Lambda _handler function. This drastically reduces cold start times because the model is loaded only once when the Lambda function is initialized. Subsequent invocations can reuse the loaded model. This is critical for serverless LLM inference. Asterisk environment variables asterisk set the model underscore name environment variable in your Lambda functions configuration to the Deepseek model identifier, example Deepseek AI/Deepseek coder 6.7b base. This makes the code more configurable. Asterisk parameter handling asterisk the Lambda function receives the input parameters in the event object. The code parses the event to extract the prompt and other generation parameters. It uses the .get method on the dictionary to provide default values for parameters that might be missing in the request. Asterisk error handling asterisk the try, except block handles potential errors during code generation. Asterisk memory allocation asterisk increase the Lambda function's memory allocation to at least 3 GB or higher, depending on the model size. You may need to experiment to find the optimal memory allocation. Asterisk timeout asterisk increase the Lambda function's timeout to at least 60 seconds or longer, especially for generating longer sequences. Asterisk deployment package asterisk create a deployment package, zip file, containing your Lambda function code, lambda_function.py, the transformers library, and its dependencies, and any other necessary files. You can create a layer for the transformers and torch packages to avoid including them in every function's deployment package. Asterisk API gateway asterisk configure API gateway to expose your Lambda function as an HTTP endpoint. Important considerations for all deployment methods asterisk. Asterisk monitoring asterisk implement monitoring to track the performance of your Deepseek deployment, latency, throughput, error rates, resource usage. Asterisk security asterisk secure your API endpoints with authentication and authorization mechanisms. Asterisk rate limiting asterisk implement rate limiting to prevent abuse and ensure fair usage of your API. Asterisk cost optimization asterisk monitor and optimize the cost of your deployment. Consider using spot instances or serverless functions for cost savings. Asterisk model updates asterisk have a strategy for updating your Deepseek model, example when a new version is released. Conclusion asterisk. This comprehensive tutorial has covered the essential aspects of deploying, configuring, and integrating Deepseek. From basic inference to advanced fine-tuning and cloud deployment, you now have the knowledge and code examples to leverage Deepseek's power in your projects. Remember to adapt the code to your specific needs and hardware resources, and continuously experiment to unlock the full potential of Deepseek Unleashed. Good luck.